because depending on the businesses, some may care more about recall than precision, while others might care more about precision recall.
Yeah.
So how do you also account for that in terms of cost and benefit analysis and explain that in terms of dollar bills, right? And that was something that I never really knew until, I worked with him.
Hello, everyone. Welcome to the Data Scientist Show. Today we have Dan Lee. Dan Lee is an experienced data scientist who consults, develops, and deploys analytics and machine learning solutions for businesses. His past engagements involved delivering social network analysis for the U.S. Marine clients at the Pentagon, tackling fraud with machine learning models for a large bank, and solving financial modeling problems at Google. He now runs a business called Data Interview, an interview platform for data scientists, data engineers, and machine learning engineers. Welcome to the show, Dan.
Thank you so much for having me as a guest, Aliana.
Let's start with your career journey. How did you become a data scientist?
Oh man, how did I become a data scientist? Well, to be honest with you, I chased the bling bling, the dollar signs of becoming a data scientist. I think, I went through the transition in my life where this was like before 2016. So I was like in college, the regular 4-year undergraduate track, right? And I was very lost in terms of what I'm going to do. Am I going to be a doctor and am I going to be a lawyer, or am I going to be a loser? And then right around the third year in college, I was studying like statistics as a minor and just, pursuing psychology as my sort of like a full-time thing, thinking that I'm going to be a psychologist, right?
Yeah.
And then I just sort of Google searched like hottest job for the next 10 years. And then like I read this Forbes magazine about like how data scientists is like the hottest job of the 21st century, and the compensation was just like, holy crap, 6 figures, And so I'm like, all right, well, I do want to make a lot of money and not end up with a lot of college debt. So I just kind of thought, hey, why don't I make a bit of a pivot here? And then sort of, weave my way into data science.
Yeah. Thanks for being transparent about your objective. I think there's nothing wrong about wanting to make money when thinking about your career transaction, right? Because you do need to pay for your, student loans, and you can help your families have better lives.
Yeah. But I just want to mention that, of course, money aside, I did take some like intro to data science courses, and I love how interesting it was. Like I love the type of stuff that I would read about, like data storytelling. There's like an article, there's like a publication called 538, Nate Silver, who basically correctly predicted which state is going to basically, vote for which presidency. I think this was like 2008 or 2012. I can't remember like which presidential election it was, but I believe he was like 100% accurate about that. If I'm correct about this details, I'm a little bit hazy right now. Please just comment it below and just say, hey Dan, you're off. but anyways, but yeah, like he had this publication and they were churning out these articles that were very quantitative driven, and I just love like making sense of numbers. And I was like, hey, you know what, like this is really fun, this is really fascinating. And that was another thing, like I became really passionate about it.
Yeah. That's awesome. So recently you worked at Google. Can you tell us your day-to-day at Google as a data scientist?
Yeah. So my day-to-day, at Google, okay, so there's like a pre-COVID and a post-COVID, and I just said the pre-COVID was just kind of like a data, like what you might see on a day-to-day experience of a Google software engineer or Google data scientist. You walk into the building and it looks like a spacecraft because it looks like a spaceship because it's not like a cubicle, so you go find the coffee shop because you need a shot of espresso in order to crank out some code and some work throughout the day. So you get that, you go to the gym. And then around like 9 a.m. is when you have the first meeting. So this could be like some stakeholder meeting, or it could be like a team-wide meeting, depending on the week of the day. day of the week. And then from there, you basically start out your first kind of project, the project that you're working on, you get lunch, you crank things out a bit more. And then you basically just kind of end the day by taking the Google shuttle bus back to your place. So that was kind of like a day-to-day, I would say like a typical life cycle of like, what I was going through back when I worked at Google.
Yeah, thanks for sharing that. So you were solving financial modeling problems at Google. Can you share with us what are the problems you were trying to solve and what were the impact?
Yeah, that's a really good question. So a lot of the data, like a lot of the projects that I worked on involved like financial data. And so naturally, if you think about like financial data, it really comes down to like two aspects. So you're trying to make some forecasts about like, what would be the projection of certain revenue or like a cost or something like that. Or it could be like analytics in the form of, what are the drivers of a certain revenue change from previous year to the current year. And fortunately, like I had an opportunity to work on, both. So on the forecasting side, I was working with the network equipment team within Google's technical infrastructure. And what they wanted to do was like a 5-year projection in terms of, what is going to be what is called like a capital expenditure. So it's like a form of cost, and capital expenditure is basically what they need to invest in order to accommodate for additional traffic that they need to, that are gonna increase in the long term. And so how much do they need to invest today in order to accommodate for the new rising traffic in the future? And so the clients initially, so I was working with the team of financial analysts, and they basically had they were crunching numbers on Google Sheets, right, with a lot of sort of heuristics about like what the approximate projection would be, but it wasn't a modeling based. And so this is where a data scientist like myself would basically build out like a machine learning solution for that. So that was like one of the, I would say, it was a highly visible project, and it was something that I definitely enjoyed. Very challenging, I have to say, because I was working with the finite data points, and there was no like exact sort of patterns that this would kind of follow, that you could just toss that into like a basic time series model like ARIMA or something like that. Definitely required a little bit more sophistication as a way to like solve this problem, but ended up doing that. And then the other type of project I worked on involved like revenue analytics. So I was building this type of capability. So a lot of like financial analysts, like what they love to do is like they love to like do retrospective analysis in terms of, okay, we see that, hey, the revenue or some cost grew by like 30% year over year. Why, right? They always want to be able to explain that, right? And there's like a manual way to do it, which is like doing some segmentation analysis by some geography or device or whatever it is to do that kind of analysis. But it can be very manual, and a lot of them were crunching numbers on spreadsheet. And so this was like a 2-part thing where one, can we figure out what would be a really good algorithm to basically automate this process? And 2, can we build like a web application where they don't have to plug numbers into a spreadsheet, but they can just load a data set, and then you get the output right off the bat for that type of analysis and interpretation and reporting. And so that was another type of, kind of financial data that I was working with.
Interesting. So sounds like the first type of model you use time series models like ARIMA, and the second one is focusing more on the automation and even dive into web application tools.
Yeah, and I just want to correct that. For the first project, it was so although I was using time series model, the specific type of time series model I was using, it was called a Bayesian dynamic linear model, Bayes DLM. For those who are
I'm not familiar with that. Can you tell us what it is?
Yeah. So basically, Bayesian dynamic linear model, it's basically a linear model, except with typical linear model, it's like, ordinary least squares, right? It is a way to approximate what the beta coefficients of this model is going to be. And the underlying assumption is that your parameters are fixed, your parameters are known. And so therefore we're going to use data as a way to approximate what that parameter value is going to be. But in the Bayesian world, you don't really think about it that way. In the Bayesian world, you don't know what that exact parameter value is going to be. So you assume that the parameter value has uncertainty to it. So that's what this Bayesian dynamic linear model is. Now, what does this dynamic part mean? Well, the dynamic part is basically the time series component, which is that, which is basically this parameter value is shifting from one state to the next state, from each time point to the next time point to the next time point. And so it uses these kind of properties as a way to make that projection. This algorithm I stumbled upon as I was going through TensorFlow probability library, and then there was like a really good tutorial about that, and then I ended up testing out the approach, and it worked out really great.
Oh, that's awesome. Thanks for sharing. I learned something new. So how does this approach compare to ARIMA or other time series model?
Yeah, that's a good question. So we have to kind of think about the fact that I'm doing a 5-year projection, right? When you think about most of these time series forecasting projects, like you're often working with like a daily granularity along with, okay, I have like 3 years worth of let's just say you're making some projections about how much sales you should expect from a given item on Amazon.com, right? Like most often you're going to have like 2 years of like daily granularity, right? And then the type of problem you might work with is like, okay, I'm going to project what the sales value is going to be for the next 30 days, right? In that case, I mean, that's pretty straightforward. Just plug that into like ARIMA, right? ARIMA, or you can use LSTM. You can even frame that into like a regular regression model, like random forest or something like that, right? But the thing is that what the type of data I have is basically 5 years of monthly granularity, and I'm using 5 years to make a 5-year projection.
Right.
So you cannot just use the typical type of model, because you need to be able to do extrapolation, kind of like what a linear model can do, except linear model, you can't really work with this type of data set I have, because it's very volatile, a lot of weird shapes. And so you can't just do like a straight line projection, or think about it in terms of like, you do some transformation, like log transformation, and then do the projection that way. It just doesn't work that way. That's why this model is really, really helpful in this case.
Yeah, cool. And you also worked on fraud detection problems. Can you share a little bit about that?
Yeah. I mean, I can just go on and on about it in this beyond just a little bit, because I would say this was really the gateway for me to understand. It was like, I would say like working on fraud problems was like a pivot in terms of just massive growth in my career of data science. Because I became a specialist in this when I entered a startup called Simility, which would later be acquired by PayPal, and then I became a PayPal data scientist. And basically the type of problem that we worked on were, we primarily work with banks and sometimes e-commerce, and they basically have some bad actors. So in the bank world, typically these are individuals who are applying for credit card applications with an attempt to open an account, use it like a regular person, and eventually like max it out, right, without paying anything, right? And so the type of so there's all kinds of fraud problem. Actually, there's like first party fraud problem, there's third party fraud problem, there's chargeback fraud, there's account takeover, there's all kinds of fraud. And but generally the elements that I ended up working with are, okay, let's think about it in terms of all these kind of potential signals that can be useful in detecting fraud-like behavior. So maybe it's like, you see that a given user account is associated with an IP address that is associated with some other user account that has been banned in the past, that has been flagged as a fraud, right? So by that association, what is the probability that this particular account that's just been newly open is a fraud, right? And so I was working with part kind of sort of understanding about this network diagram. I mean, believe me, when you look at these network of like IDs, like device ID, IP address, email address, user account, and you plot that into like a network graph, I mean, it kind of sucks that these bad guys are stealing millions and millions of dollars, but at the same time, visually it's pretty cool to look at. I'm not gonna lie. But anyways, like you basically capture that into this statistical model, and then you build this probabilistic model saying, okay, based on these XYZ conditions, known properties from the social network along with known current behaviors about this fraudulent individuals, what is the probability that this person is a fraudulent actor or not, so I was doing that type of problem for about 2 years before working at Google. And around that time, I think this was like a pivotal in terms of just like massive growth in data science. Because this was also the first time I was working with like productionized model system. I was working in a startup environment, so I was working on multiple projects at the same time. And I worked with the director of data science at the time, who just really like shaped my understanding about how do you think about things quantitatively. How do you approach a problem with precision, and so this was a really good opportunity for me.
Yeah, thanks for sharing that. And you mentioned you learned a lot from this director and how he shaped your problem solving skills and how do you approach problem. Can you share some specific things you learned from him?
Yeah, definitely. So before working with him, like a lot of the type of problems that I often work on were retrospective, like observational studies.
Yeah.
But now it was like a pivot to, can you make some predictions in real time, right? So in real life, like you have new observations come in and you need to make some prediction right off the bat, right? And so this was like a whole new framework for me, right? And the thing is, a lot of my experiences were based on things that I might have picked up on Kaggle.com or projects that I've worked on during my consultation years before working at the startup, and so. He like gave me a lot of exposure in terms of, how do you build an actual productionized model? Like what are some checks that you need to do in order to ensure that your model is accurate and stuff like that. And at the same time, he helped me cultivate quantitative thinking. And I think this is perhaps one of the most underrated skill set out there in data science, because I often see a lot of articles about I don't know, maybe I should also write an article about this, but I often see a lot of articles about, how do you understand this algorithm? What are some techniques for A/B experiments, stuff like that. But how do you actually interpret numbers? How do you make decisions based on numbers? So couple, instances could be like, for instance, if you're doing like a classification model, right? Like predicting whether an individual should be fraudulent or not.
Yeah.
Most people, what they would end up doing, and I know this because I conduct a lot of mock interviews and ask a lot of classification problems, and what people actually end up doing was like, okay, they just sort of assume that the model is going to poop out a binary value 1 or 0, right? But the model by the default, if you're using, like assuming you're using the sklearn and a lot of like open source libraries out there, will basically classify the threshold is based on 50%.
Right.
It's greater or equal to 50%, so therefore it's going to be 1, right? But how do you know if that's really optimal? What if you don't want to do 50%? What if you want to set the probability value at 80% or greater, right? Yeah. And prior to that, like I was thinking about it in a very naive way. I'm like, okay, the model thinks 1 and 0, so it's good, right? But turns out that there's a lot more intricacy behind that, depending on whether you pick at a 60%, 70%, 80%, 90%, and so forth. You also want to look at like the precision and recall, but you don't just want to stop there because depending on the businesses, some may care more about recall than precision, while others might care more about precision recall.
Yeah.
So how do you also account for that in terms of cost and benefit analysis and explain that in terms of dollar bills, right? And that was something that I never really knew until I worked with him, and he helped me really understand, well, first of all, based on who the audience is, what the business objective is, how do you turn this mathematical machine learning problem into something that a business can understand And that's what I mean by quantitative thinking, quantitative business decision making. And so to this day, a lot of, I would say, like what I ended up doing at Google, but also what I do within my business as well, really boils down to that. I don't just make decisions because that's what my gut feeling tells me to. Do I have data points to back it up? And if that's the case, like what is the approximate sort of ROI I should expect based on that?
Yeah, I'm so glad you mentioned this point. So a lot of times when we think about the results of the model, it's the accuracy, precision, and recall. But how do you translate that into a dollar amount and ROI? So for example, if a business cares more about some potential loss when you have a false positive, what is a loss for one false positive you predicted, right? And what is your investment in this business? What's the investment in this project? Now you can calculate the ROI and tell the business, hey, if you want to invest in this model, this is the potential risk. And that's how the business make decisions. And that's how you communicate those points to get buy-in from the business.
Right, exactly. And I just want to add on that real quick, though, so I work with two different types of clients. So one was a small e-commerce platform. The other one was a large bank. They have an army of reviewers. They can verify the labels that we're sending them, right? So let's just think about this for a second. So imagine you're building this classification model for these two different entities, and one has a small team of reviewers and the other one has a large team of reviewers. In that case, how would you optimize what the threshold is in terms of precision recall?
Yeah.
Well, in the first case, they have a limited staff, right? So you wouldn't necessarily want to send them labels, predictions with 1,000, 1,000 predictions saying that, okay, these are fraudulent users, right? Because that's a very small team. And so you would, first of all, make some estimation in terms of, okay, how long it takes for each individual in the team to basically review a case, right? And let's just say it's like 30 minutes or something like that. And let's just say the team has like 5 people. So you can imagine if you send them 1,000 labels like on a daily basis, it's gonna fill up their queue, right?
Yeah.
So in that case, it doesn't make sense to optimize on recall. It makes sense more to optimize on precision, and then only send them a subset where you know that to a large extent, let's just say the precision is gonna be 80% or 90%, right? Much better to do that by raising the probability threshold. And so therefore you would end up only sending about 100 with 80 to 90% certainty that these are going to be fraudulent labels. That's the bigger ROI for them than sending them 1,000 or 10,000 in the case, right? But if it was like a large bank and it's much better than current baseline, and you know that your precision recall are both higher than what the current baseline is because the review itself is being done by the manual review team, right? Then it's okay to maybe lower the precision at a bit of a higher recall just because they have the capacity to be able to accommodate for that many number of observations that you're sending them. So that's what I mean by the trade-off. And I would have never really understood that subtlety until I had a chance to work with them.
Yeah. Thanks for sharing that. And also, if you think about classification problems, right, there's never a classification problem. It's always a probability. And a lot of times when we just start using those libraries, we just use the default. So for data scientists, it's important to challenge what are the assumptions we make, what is the assumptions the models make, and then to dive deep into that and then to see, okay, is this really what I want?
Right. Precisely. And I actually just want to add one point on this. Are we allowed to talk a little bit more on that? Because I know, for the viewers out there, you guys are either machine learning enthusiasts, data science enthusiasts, or current practitioners who are trying to cultivate more on this side of kind of data science technique. But the other aspect in which this is really important is like when you're kind of making decisions about how you're splitting the data as well. So what I mean by that is, when you're working with these sort of highly imbalanced data set like fraud, where you either have like a 1% target value or maybe even less than that. I've worked with the type of data where it's like less than 0.1%. Then in that case, you really need to think about how you're splitting data, and you can't really use cross-validation because the thing is that fraudulent patterns are changing over time. And so ideally you want to have your holdout set, your test set, by splitting on time. So where your test set is based on the most recent data points and not based on something in the past. Otherwise, you're kind of, making the model cheat. But anyways, if you're doing that, then you want to sort of optimize on to what degree you want to split your data. Do you want to do it on 60-40% split, 70-30, 80 or 20? And a lot of it sort of boils down to like, what is the size of the data set along with what is the percentage of that labels? Because what happens is like, if you have a very small labels, so let's just say like your label is like 0.1%, and then, you have like 10,000 observations.
Yeah.
And then you split that into like, let's just say like 60-40, then that's not going to be ideal because you're not allowing the model to be exposed to enough of the labels, right? So in that case, maybe it's much better to do it at like a 80-20 or 90-20, 90-10, train to test split, right? So that's also what I mean by these kind of subtle things that you pick up when you begin to kind of understand how do you interpret numbers through the beginning to the end cycle of the data science. It's not always about the beginning part or the end part when you're working with the stakeholders, but also when you're making each incremental decision in your modeling project or your analytic project, you always have to have this quantitative thinking on. Yeah,
that's a great advice. And for someone who wants to improve this quantitative thinking, what are some advice you have for them? How can they practice this?
Yeah, I mean, very simple. Just open a Robinhood account and start making some predictions in terms of whether Tesla stock is going to go up tomorrow or not. I mean, so I would say like for me, work itself has sort of forced this in me.
Yeah.
I was not always the strongest person when it comes to math or quantitative thinking. This is something I cultivated through work. I think there's a couple things here. So one is definitely read more literatures out there. So I'm talking about 538. You read any journals or articles that are data driven, and really understand like how they are like interpreting numbers. Like really observe and dissect like how they're doing that, and see if you can also do that too.
Yeah.
Second thing is like if you have some general curiosity about how things work in general, like maybe you want to try to understand an election outcome or your COVID confirmed case, actually take the time, like download a data set and do some interpretation, right? And see if you can make some projections. And I'm not saying like publish those out there on the internet because you might get a lot of like hate emails or people sort of thinking like, oh, well, I don't know why you're doing this, stuff like that. But anyways, like, these kind of exercises can be really helpful. That's how I've also kind of cultivated the quantitative skill set. And the third most important thing is that when you're working on real life project, just, don't just look at a graph and then just kind of have a vague sense about what you're looking at, like really break it down in terms of number. So what I mean by that is like, if you're looking at like a distribution, right? And more often than not, like distributions may not be like normally distributed. It might be like skewed in some sense, right? So look at it in terms of quantiles. So look at it in terms of cumulative distribution, and then see what is like the minimum, the maximum, the 90th percentile, the 50th percentile, the 10th percentile. What is the variance? What is the standard deviation? And that's something that I do always right off the bat. And I should remember that because that was something that this this director that I work with, like that's what he was really, really sharp at, which was you could ask him, what is the distribution of some variable? Like he would be able to just right away just recall the stats behind that. And just do a lot of number crunching. So that's another aspect of it as well. Just doing a lot of number crunches also help you in some ways, like cultivate a lot of the quantitative thinking.
Yeah, that's very helpful. And previously also mentioned in the startup, you also learned from this director how to do checks when you put model in production. So can you share some best practices when you want to productionize a model?
Yeah, so a couple of things. So you always have to make sure that whenever you're building an offline model, you're not producing any potential leakage. I think this is something that a lot of kind of beginning data scientists sort of overlook, which is like, oh, I'm going to basically start pre-processing the data and then like scale it and then split the data. No, that's a no, because if you do that, you've essentially, so assuming that you did like a standard normal scaling, like that means that you had to basically computed what the mean is across all the data set, and then you split the data. You just introduce leakage right off the bat. So always start by splitting the data from the get-go, leave the test set out, and then ideally that test set should be the most recent time points, and then build your offline model the regular way, right? And then plug that raw value into the same funnel that you did with the pre-processing. So if you're doing standard normal and some continuous variable, let's just say x1, and your mean came out to be 2.0 off the train set, then make sure you're applying the standard normal scaling on that test set with the mean being 2.0, right? Not the mean of that test set, because you don't have exposure on that in real life. So basically applying the same funnel, right? So that's one thing you need to do. You need to make sure you do. All right. So let's assume that you built your model that way, and then you're doing some evaluation. So make sure you're not undersampling. You're not like under training or overtraining the model. And you can simply look at that by looking at the error rate of the train performance and test performance, and see there's no big discrepancy between the two. If there's big discrepancy, you're either undertraining or overtraining. So that's when you need to do the additional tweaks there. And then towards the actual launch, pushing the model to production, it really depends on the production environment. At the startup, we primarily work with H2O, which is like it's like an open source service that allows you to like build models. Kind of, they have like this nice elegant UI. You press certain buttons and then you get kind of this model file. So you basically push that in, and then you do some tests. So you get your calculation. You get your online calculation, your offline calculation, and ensure that the values actually match. If you were to put in the exact same input values, if you're seeing discrepancy, then that's a sign that you did something wrong, either in the offline stage or when you push a model. So you have to make sure you reconcile in that, and make sure there's no issue with that. And then depending on the production environment, sometimes like you might have to add like unit testing as well for each of the pre-processing code. So that's something to do. And then it doesn't stop there. Once you push your model, and from there you need to do some monitoring, right? The last thing that you want to do is like, your model performed really well, but then 3 months out, your performance begins to decline because either the data patterns have changed, or you might not necessarily have accounted for something when you're doing the model exercise. So those are all of the things that you should definitely go through when you're building a production model.
Yeah, thanks for sharing that. And so what is the project cycle look like for your project, say from brainstorming with the business to putting the model in production?
Yeah, that's a good question. I would say it kind of follows like a sandwich method. So it's like, okay, in the beginning, it's always technical business. And so what I mean by that is like, you start by approaching the business with a couple aspects. So first of all, do they have a problem that can be solved using data science, right? And you can sort of gauge that based on a couple key questions, like do they have the data set? Is there a priority for the business to solve this right now, or is just kind of nice to have?
Yeah.
Right. And I definitely want to come back to this part because this is something I made a mistake on in the past.
Yeah.
And the third aspect is your current bandwidth and interest as well, because sometimes you do get like options about, do you want to work on this project or that project or this project, right? And when you're in like entry level phase, like it doesn't really matter what you work on, but as you sort of go like kind of mature through your career, like you do want to be a bit more selective about what project you want to work on next, because your level of, I guess, like promotion capability, all of those things is somewhat dependent on like the impacts that you bring through the project. And if you just only end up picking an easy project with low impact, then that might not be as like a way to grow versus if you were to pick a project that was a bit more complex, but it's going to have a high impact, right?
Yeah.
So it's about doing this sort of kind of the investment time versus the impact that you be able to bring. So you need to be able to do that sort of analysis. So you do that initial kind of screening, right? And this might be in the form of like 1 to 2 meetings with the stakeholder, and they're gonna begin to kind of provide more details about the project. So in this case, like, what do you do, right? Because a lot of the times, like, they don't give you the problems in the form of like what Kaggle does, right? Like, here's a data set for you. Here's a problem statement. Here's the evaluation. No, it's almost like very open-ended, right? And so you yourself need to do your homework, and you need to ask them for any sort of documentations, whether it's like some Excel, some number crunches that they have done in the past. What is the current business process, access to the documents, access to whatever data sources that they may have. Get all of those things and start doing your homework, do your research, right? If you can Google search things, do that instead of asking the stakeholder, I don't understand what this means, because you want to show expertise. You have to approach it like a consultant. You do those things, and then from there, the next step is to basically frame the problem. So this is where you would draft something called a business requirement doc, business BRD. And this kind of outlines what are the key things that you want to deliver and what's the timeline. And then you get that sign off. And this also serves as like your scope, right? And this is really important because if you don't do this, later down the road, you're going to go through a lot of hassle of like a stakeholder wanting to get more out of you when it's just clearly out of scope. So if they've signed off and you've signed off, then that's an agreement that this is exactly what you're going to deliver. Okay. And this is also an opportunity to call out potential risk. It's much better to call out potential risk that you might not be able to build certain models that might work out if XYZ condition doesn't hold. Like, you simply don't have enough data or something like that, right? Much better to call that early than later down the road where they've been waiting 3 months and you say, I'm sorry, I couldn't really do anything because I just don't have the right data, right? So this is an opportunity to call all this out. All right, so that's great. This is the beginning part, the business part. The next step, the data science, the actual dirty work. You pre-process, you do a lot of exploration. You are doing typical procedures like you're looking at scatter plots. What I love to do is I love to look at quantiles. I like to look at distributions of data to make sense of it. I'll even try to remember some of the numbers. It helps me build a lot of intimacy with the data set I'm working with. And I also build a lot of like stories about, so if I'm building like a forecasting model, then I build a lot of stories about, hey, you know what? Okay, what do I believe would be the drivers of cost, right? Okay, so I know that I'm building a network equipment model, CapEx. So I think obviously one thing that I can look at is, basically like the current network traffic. Given that the network traffic has grown by 20% month over month the past 3 months, what is the projection is going to be based on that the next 3 months, right? So I might do some like a lot of kind of heuristic based data exploration, kind of make sense of that pattern, do a lot of correlation analysis. So once I have a really good sense and really good story about the data that I'm working with, the next step up for me is start doing some very quick iterative model. Really, the modeling procedure should be very fast. I'm testing all these different approaches. So I'm plugging in some features and I build my initial model. I might start the very simple model. It could be random forest, or it could be like GBM, XGBoost, or CatBoost. I recently read a post about your stuff. Yeah, I also recommend CatBoost, guys. Anyways, so I build that initial model, get the initial evaluation, right? And then I just keep iterate as much as I can. And every time I'm iterating, I always have like Excel spreadsheet. I have a scoreboard. I'm tracking like what the values are and whether it's increasing over time. And of course, like as I'm doing the iterations, I'm testing different models, I'm testing different signals, I'm testing different basically like hyperparameters, and the type of hyperparameters I often work with are either random search or Bayesian hyperparameter tuning.
Yeah, it's like a tongue twister.
yeah. So I use those strategies as a way to find the optimal parameters. And once I feel that I have a good enough model, and typically you know whether you have a good enough model by looking at what is considered like a business baseline. Or if they don't have a baseline, then you just basically get the number from the stakeholder in terms of what they believe will be a reasonable value for success, right? And you can kind of guide them through that procedure as well. And if you beat that, then, hey, you have a working model. And so now you have like a final presentation in terms of what is like a deliverable. But I just want to let you know that, there's no like, oh, I have a meeting with the stakeholder in the beginning and the meeting with the stakeholder at the end. You're also engaging them like throughout the process as well. Like more like in a weekly cadence or like a monthly cadence. It really depends on the stakeholder, but you're helping to follow the journey of this data science project from the beginning to the end.
Mm-hmm. Yeah, I think that's very important because stakeholder alignment doesn't just happen from the beginning to the end, because sometimes the business goal changes, and if you don't communicate, you're building something that's going to be useless in the end. And also the stakeholders, as they work with you more, they might also realize, the objective they proposed previously is actually not something very important, and they might be inspired by your project and then propose something else. So you want to work with them continuously and to get their feedback.
Yep.
And I love that previously you mentioned when you do data exploration, you look at quantiles. Can you share more about what specifically are you looking at when you look at quantiles?
Yeah, that's a good question. So when I'm looking at quantiles, like as I sort of mentioned earlier, like I'm looking at the min max, I'm looking at the 10 percentile, 20 percentile, 50 percentile, the 80th and the 90th. And I also look at the means as well. And this kind of gives you an idea about what is the type of distribution I'm looking at. Like, is it like a normal distribution? Is it truncated is it inflated at a certain value? Toward the extreme, is it sparse? What are the presence of the outliers?
Yeah.
It gives me a very mental picture in terms of what the distribution looks like, and depending on what the distribution looks like, it is ultimately going to determine the type of statistical procedure I might use to explore a little bit further. Because, for instance, if the distribution is very skewed with a lot of outliers, then I know I can't use Pearson statistics right off the bat. Because if I'm using Pearson correlation, then if there's presence of outliers, then that's going to skew the Pearson correlation value quite a lot. And so you get this false reading that, there's statistical significance in the correlation of the X1 and X2 variables. So in that case, I might opt out of that and use Spearman correlation, which is a lot robust, more robust against outliers, or do some sort of scaling, right? Mm-hmm. So that kind of gives me some understanding about, the values that I'm working with, the distribution I'm working with. That's like, that's basically one way in which I'm looking at the distribution.
Yeah, thanks for sharing that. And previously, you also mentioned that when you explore the data, you don't just do the standard thing, look at some bar chart, some distribution. You come in with a question. You have a story to tell. Can you share more about, when I look at the data, how do I form those type of assumptions to help me, get more insights from data exploration?
Yeah, that's a good question. So I would say this is a common sort of sticking point for a lot of starting out data scientists. Like, it was certainly something that I struggle with. Like, I downloaded this data set off of Kaggle. I'm like, oh my God, I'm so excited to do some, deep dive on it and uncover an insight. The keyword insight is such a hot term. But then I'm like, I don't know what I need to be doing. I create these plots and they're like just some bar chart, and they don't look as sexy as like what you might see on someone's Medium article,
Right.
So this is like what I do. So right off the bat, like I still go through the regular stuff, which is like, I look at, I don't I look at the bar chart. Sometimes I look at scatter plot. So for me, I have a very kind of typical procedure. So I will look at the missingness of the data, right? And that's very simple to do. I will look at the quantiles, as I mentioned. I'll start doing some univariate analysis. So I guess in a way it's like looking at quantiles as well. So sometimes I might look at the visual distributions, visually, right? Like histograms and stuff like that. And then I might do, I might start putting some, basically bivariate, distribution. So I might look at, okay, I might pick out two variables together and see what they look like, right? By looking at it in terms of like a scatter plot, right? And that kind of gives you some initial screening about, okay, what is the condition of data? What are some potentially interesting things I can dig a little further, right? So suppose that I find that the target variable, so once again, kind of going back to the forecasting example, this CapEx is correlated with traffic, then I would want to basically look at it in terms of more in depth, right? Like let's look at it on a daily granularity versus monthly and then yearly and see how the patterns change over time. And then I don't just stop there. I think what most people might end up doing is like, oh, okay, I see some generally positive trend, right? But what I do further is like I start to segment it by time period. So does this hold true for 2021, 2020, 2019, 2018? Are there certain period in which it was a lot more volatile than usual?
Yeah.
And then and that brings more interesting question, right? All of a sudden it's like, let's just say that like 2018 was like it was positively correlated, and in 2018 one is going up but the other one is going down. What's going on there? Why, right? And this is an opportunity to investigate further. You can extract this information by doing more exploration through data, or this is an opportunity to engage a stakeholder about it to see if they might have some additional input. And if they have some additional input and it's not something that's necessarily captured by the data, then hey, maybe it's an opportunity to ask additional data signals that can be useful. So that way you're building a much more robust model as well, right? So really, if it's, if when you're talking about like a modeling project, like this is also a data storing exercise as well. So you're basically giving stakeholder reasons why you're putting these signals, because through data exploration, you found that there's a lot of correlation between these two signals. And they have meaningfulness to it, right?
Yeah.
It's not just some random signal where, hey, it turns out that network CapEx is correlated with diaper sales, so that way we should put that. No, you shouldn't, right? There just has to be some business connection in terms of why you added that signal. And so that also provides some idea in terms of the type of like storytelling or analysis that I might do during the EDA stage.
Yeah, thanks for sharing that. Previously, you mentioned you have made some mistakes around figuring out whether you should work on the data science problem. Can you share more about that? What are some mistakes you made?
Yeah, so there's one concrete mistake I made, which was like in the beginning, like I was working in a consulting firm, and like I had a couple projects that I could definitely, plug into. And I was sort of allured back then. Like I was very allured by like algorithms. I was just like naive person, like, oh yeah, like I know like 48 different unique machine learning algorithms because I worked out all the mathematics. So although there was a lot of benefit in doing that, right? But my sudden sense of like, oh, what is about data science is about knowing as much algorithms as I can. And so around this time, like there was like a project that worked with this proprietary algorithm, which I'm not going to get more into. But anyways, it was about like sort of proving out whether this algorithm can be useful for this type of project that involve accounting data among the U.S. Navy. So the project focus, the primary scope was data migration. Let's migrate this old data with this accounting data and this old legacy system to this new system. That was the focus of it. That's where the client invested most of their research on. But without getting into too much details about it, but there were certain individuals in the stakeholder, like among the stakeholder, who thought that, it'll also be interesting to do some data science out of it. And in the beginning, I didn't know exactly what the purpose was, except he basically sort of framed it as, you're a data scientist, you should figure it out. So, okay. I'll somehow do some data science. And so like I basically had to like try to come up with some interesting research questions to look at based on the data set I'm exposed to.
Yeah.
But without a clear sort of, I guess stakeholder, it's not that the data scientists, data scientists, like at the end, they need to know a direction in terms of what they need to solve, right? Mm-hmm. Like that, it's like their job, but they're not really the ones that set the vision in terms of what it is that you need to be doing. Like that kind of vision and that initial inspiration comes from a stakeholder most of the time. And without that, then it means it's a bit problematic, because it means that among the stakeholder, there's no clear backing on the type of effort that you're going to be doing. And so you might apply some fanciest algorithm out there and come up with something very insightful, but if there's no dedicated resource to turn your insight into something that is actionable, then you just basically did a project that's no different from what you might have done in college, where you might have done some interesting analysis, but it's not a real life application, right? So that's kind of like what happened. There was no clear impact to it, and that project really went nowhere. I mean, it became a migration project, but in terms of this data science part, it was auxiliary. It was optional. And so being able to clearly understand, okay, if I'm going to commit to this project, think about it. Like, you're going to invest the next couple months of your life for this project.
Yeah.
Like, you better have some sort of experience out of it. You know what I mean? Experience or some impact, right? Mm-hmm. So that's something that I did not properly do. And then now that is something that I rigorously do.
Yeah.
It's kind of like dating in a sense. Do you really want to date this person? You usually know based on a couple dates.
Some early red flags.
Yeah, exactly. Look for those red flag guys.
Okay, but then I have another question. A lot of data science project, for example, there's some project I worked on was initially very ambiguous. We know this might be a little bit gambling, but it turned out to be good. So I think sometimes it's so useful to invest in this project. So how do you differentiate those projects that's vague but worth exploring versus those ones that are just gonna be useless?
Yeah, so I would say the other aspect of it is like look to see if this type of problem that you've worked on in the past or your colleague has worked on, and sometimes like if this is type of problem that you feel like is going to be one met with a lot of resistance and it's going to take longer than it really should.
Yeah.
Then maybe that is a project that you need to sort of set aside and work on a project that's a bit more easier, but that you can just quickly churn out. And that also kind of depends on the type of support that you're going to get within your team as well.
Yeah.
If it's a type of team where it's a lot more focused on just quick turnaround, quick deliverable cycle, then the last thing you want to do is like you want to plug yourself in an R&D project and it's taking you six plus months to deliver an actual impact. The stakeholders are going to be impatient, your team's going to be impatient, so that's not something that you definitely want to do. So look for projects where that there is an existing framework and you could just replicate it and then just have the easy win. And I would say that like for me, what I had to learn was, because I'm so allured by novelty of things, I often kind of chase the R&D stuff. But to be honest with you, in the business world doesn't care too much about your curiosity. No offense. It cares about your return on investment. Yeah. So keep that in mind. Have that business thinking involved and think about it in terms of, okay, what is the quickest, the most efficient, and the most effective way to deliver something.
Yeah, I love that mental model. And also, if you worked on multiple data science projects, you can think of as your investment portfolio, right? You want to place the bigger bets, maybe 80% of your time on a project that actually will deliver business model and business value. And if you really want to explore, make sure you communicate with your manager or stakeholder that, hey, this is a project that might not lead to anything. So you set the expectation beforehand. And then even if it fail, people won't get too upset. And also, even if you worked on some project, you didn't learn anything, still make sure you document it. Or if you build some type of technical stack, think about how you can reuse this technical stack into something else. So this might still help you in your career.
Yep.
Yeah. So sounds like you have worked on a lot of different projects, faced a lot of challenges. What is the most challenging part in your career?
A lot of people see data science as like a technical thing, but at its core, it's also it's a very soft skill focused type of work as well. You know, there's many sort of points in which like having a very strong soft skills is going to be incredibly helpful. And you can often make up for it despite your lack of experience in the technical aspect of data science. Because by nature, data science at the end of the day, like we're business consultants, so it's about how do you engage stakeholders? How do you, it's not always about like what you deliver, but how you deliver things, right? Do people enjoy working with you, right? Or do you communicate things properly? Do you coordinate things properly? Do you, when you're presenting something, like, does this come out to be effective that stakeholders gain an actual value out of it, right? So for me, because especially in the beginning stage of my career, like the first 2 years, I was really focused on like the technical aspect. If there are 100 Pokemons out there, I'm going to know it all. I'm going to know all the 100 plus algorithms out there. I sort of overlooked the soft skill aspect of it. But eventually, when I, worked at PayPal and Google, I learned that, okay, this is actually probably the more important aspect of it if I want to continue to grow in data science. So I really worked a lot on it. And so that would say that personally for me, that was somewhat of a challenging aspect in data science.
And I completely agree with you, because there's always going to be another new model for us to learn. And once you have developed your foundations, you can always learn while you're working on a project. So how do you develop your soft skills?
Yeah, so soft skills, couple resources out there you can definitely use. So the Toastmasters, I think that's how we initially met Toastmasters.
Right.
Toastmasters, for those who are not familiar with this, it's an international public speaking organization. There's clubs worldwide, and basically this is an opportunity for you to like practice, prepare speeches and impromptu speeches as well. And you also get evaluation from fellow members, and you could also be an evaluator and provide feedback to the speakers during like a club meeting. But through this experience of practicing speech has definitely helped me a lot in cultivating communication skills. But also you often get these feedback through the colleagues that you work with, your manager, and sometimes directly or indirectly through the stakeholders, right? And so just doing this sort of like on an iterative fashion has really helped me cultivate soft skills. Yeah,
thanks for sharing that. And especially during your interviews, you don't just get asked about those technical concepts. You're asking about how do you approach a business problem. And sometimes there's no standard answer. And it's important for you to communicate, understand the requirements, ask questions, and especially during stressful situations, how do you maintain calm? So those soft skills are not just important in your career, but also important in getting a job. Now let's talk about data science interviews. Obviously, you have helped a lot of people get jobs, and you started data interview business. So can you talk about how did you prepare for your interview for Google?
Yeah, that's a good question. And it's often a question that I get asked a lot. So for me, by the time I was preparing for Google interview, like I wasn't a stranger to Google, like just like technical interview process in general. A couple years prior, as I worked at a consulting firm, I was making a transition to more like a tech focused companies. Like I had gone through a lot of these type of interviews where they have multiple rounds, really exhausting, and I was very like familiar with the type of questions that they're going to ask. It's going to be business case problems. It's going to have some algos and data structure questions, SQL, some product sense questions. So I had a framework in terms of how I'm going to approach it. And it was just a matter of finding example problems that I can solve, and also just sort of like extrapolating it based on the type of business that I'm going to be being interviewed for. So I always sort of approach it like I'm a consultant, because that's really what interviews are. Like, can you, given these kind of vague problems, can you like solve this? And so I knew that there's going to be essentially 3 types of problems that I'm going to be asked. So one is going to be definition-based questions. So like things that you might have learned textbooks, like what is p-value, right? There's really no right or wrong answer with that. I mean, there's a definition, you just need to recall it, right? Mm-hmm. So I had like a index card full of concepts, keywords. I had about like a deck of like 300 of them. I just shuffled through these cards, and then I would practice explaining it, because internally it might make sense to you, but when you explain it, you might sound like you don't know what you're talking about. So explaining it out loud really helps. The second part is business case problems. So this is like, I mean, even before like last year, I think, in like 2019, there weren't that many good resources out there. I found a lot of ridiculous lists of like, here are 100. I often see this getting tossed around a lot on LinkedIn, which is like, here are 120 interview questions asked by FANG company. And then you look at the top 10 questions, and the first question is like, what is pandas? Really? Do you think a FANG company is going to ask that type of question? Or anyways, so I couldn't find good resources out there. And so I had a friend who was like a business lead at Google, he was a data scientist, but I sort of asked him, hey, like, how do you, so given that like the team that I'm going to be interviewing for is finance, is under like essentially like a business ladder in a sense, right? How should I go about studying this? And he said, like, I think what you need to do is like familiarize yourself with the businesses, Google, like familiarize yourself with what are the main revenue generators, like what are the major product areas within Google and stuff like that. And so I did a lot of research in that, and I sort of formulated into potential business questions. Like, how do you know, like, how can you determine if, let's just say like Google Calendar is growing, like what is considered success? What does that success value look like, precisely, right? So I was kind of asking myself those questions, and that those sort of serve as a really good starting point for me. And I also had to extrapolate draw a lot of inspiration from consultant interviews. So like how McKinsey conducts interviews and stuff like that. And I found a really good book called Case in Point. It's a really classic book for those who want to get into the big 4 consulting firms, and had really good sort of open-ended problem, like opportunity sizing, estimation type of problems. And I was basically borrowing a lot of the type of kind of solution style and then question style, and formulating that into like a data science specific type of problems. So that's what I mean by business case. And then like the third aspect is just purely coding, SQL and algorithms and data structures. And I mean, really, there's a lot of resources out there, to help you practice that, right? And in those type of problems, there is no maybe solution. You either get it right or wrong based on the time constraint. So I did a lot of drills, a lot of them. And that's how I prepared for the Google interview. And then eventually, I went through the on-site. There were multiple rounds. There were, during the entire interview process from the beginning to the end, there were SQL questions, some actual live sort of coding style business case problem where I had a data set to like basically provide an insight rather than that. There were stat questions. There were a lot of sort of stakeholder management type of questions. And yeah, I mean, it was a very exhausting process, and I could not sleep at all the night before.
Yeah. Wow.
So yeah, so went through it, and then a couple of weeks later, got a call from a recruiter saying congratulations, and so I almost teared up on that one.
Yeah, I feel you. So is it what inspired you to create your own data interview platform to gather all the information you have learned, and then so you can share with other job seekers?
Precisely. Yeah, I felt that especially back then, like the resources were underwhelming, and it's like I felt that it was like misrepresented to a large extent. Mm-hmm. And I always sort of like to think about it in terms of like, who does this person, did the person really walk the shoes, right? Or did they just create some content out there and just preach it, And so I felt that, okay, I just walked through this experience, and I think this is good for me to turn my learnings into actual business, and also help other people really, go through this process without suffering through a lot of the friction points that I went through, And so that's why I started this business.
Yeah, that's awesome. So can you share a little bit what's inside the platform, how people can use it? For example, can I use it for SQL prep, business case? How does it work?
Yeah, so there's like two main tiers for the type of services that I'm providing. So there's like currently as of right now, there's like a monthly subscription course, and you get access to Slack community group. You get access to courses and recorded mock interview videos. And basically, Slack community is like a really great opportunity to network with other individuals, find potential mock interview buddies, ask any questions you might have, share your recent interview experiences. It's a very robust community, and you often get really fast and quality responses. I'm also very active on that as well, and I address questions. And then among courses, so there's an A/B testing course. Case in points, there's like 40 plus case in points. These are business case problems, along with like, instead of just giving you like a one paragraph solution, like I should flesh it out in terms of like a candidate and interviewer dialogue. And at the very end, I have like an assessment portion where I basically break down based on how the candidate has produced a response, what is the score on that? And then candidates who use that has found that really helpful for their interviews. And then there's a probability course. There's the product SQL. There's a mock interview recordings, and then like every month I'm always like updating content, adding new courses, and so people have been using this as like a self-serve fashion, and then going through the course. And then the next tier up is like for those who need coaching. So I provide like personalized mock interview. If you have an interview lined up for Robinhood, whether it's Stripe or whatever, Amazon, Google, Meta, I basically will personalize interview questions based on the role, the round, your years of experience, the upcoming interview, and give you an actual practice run, along with assessments and solutions that can be helpful. So that's like another experience that I provide through the platform.
Yeah, cool. So I saw that you have a YouTube of a mock interview you did.
Yep.
So out of all those business questions or data science questions, do you have a favorite one that you can share with us today? Just walk through us how you tackle the problem.
Yeah. So I can name one off of like the most recent video, one of the most recent video I put out. So this is about like, how do you measure, so not measure, but let's just say the problem is, how do you know how would you improve a product, right? So this is a very common like product data science, question. And you can like think about it qualitatively or quantitatively, and this type of problem I expect you to have both. So the first thing is like you have to be able to you have to be familiar with the type of product that you're working with. And so let's just say that an example problem might be like, how do you improve, let's just say Google Maps, right? So in that case, like you might start by walking through the experiences using Google Maps. Like, what are the core features? You know, you can search routes, you can browse places that might interest you. You can search businesses. And if you're a business, you can also take out advertisements, right? And so you start by kind of listing some core functionality, basically the user journey, right? And then think about like, what are some potential enhancements of this app, right? So a really good way to kind of think about it is like, okay, like if I was like a user, and have I ever stumbled upon a friction point where, you know what, I wish there was this feature, right? And it can kind of come from your personal experience, or it can be extrapolated through data analysis, and this might be certain events that like you're looking at. So for instance, maybe it's like you notice that people are searching for parking lots in urban areas, right? And they keep driving around, circling around the street. Well, that's a potential signal that they may not necessarily want to park at a parking garage, but they may want to find a parking spot on the street. So maybe that could be some sort of feature that the Google Maps team can invest in, add as a way to remove friction points for users. So being able to kind of quantify your initial sort of inkling about what could be a useful feature. And then basically, you know, you would list like 2 to 3 features, and then like provide like a prioritization in terms of, you know, what you expect, what should be the feature that you should invest in based on cost and benefit analysis.
Yeah. Great. And now there are different type of data scientist related roles. There are data scientist, machine learning engineer, product scientist, product analytics. So can you share with us what are the differences among those roles, and how do you prepare for those roles?
Yeah, that's another good question. So I would say just in general, like product, whether it's a product data science or just general like analytic role or machine learning engineering role, a lot of the core foundation are pretty much the same. Like you need to know SQL, you need to know some programming language. It could be Python or R. You need to know, you need to have a strong grasp in statistics, and you need to have a really like a base knowledge about machine learning. So, you know, stuff that you might have learned if you read the book, Introductory to Statistical Learning.
Yeah.
And then from there, it kind of branches out depending on what is the role that you're picking at. Like, so if it's like a general analytic role, like what you have covered so far should be good. Just need to essentially a bit more on the business case problems. For product data science, definitely the business case part, but also product sense. And product sense, you can kind of cultivate it by like using the product often, researching, like, you know, like really deconstruct it as though you're like a UX researcher. What are the core features? What are the type of data signals that this feature is collecting? What is a user journey from the beginning to the end? And then think about like, what are the concrete metrics that you can measure off of this feature, right? So that's like way to cultivate product sense, but also you need to know like A/B experiment. That's another area that you need to familiarize yourself in product data science. And then for machine learning engineering, it's it deals a lot with more on the machine learning part. So understanding advanced algorithms like neural network is going to be really helpful. And also some like system design. How do you build a scalable system? That's another component in which you should know for machine learning engineering role.
Yeah. So what are some mistakes people make when they do data science interviews?
I would say that there are definitely a couple of sticking points that candidates are making. As you know, I've conducted a lot of mock interviews for candidates, and often they kind of dive into the solution without approaching it like a consultant. So you definitely want to, first of all, try to understand the problem in the form of clarifying questions, and along with some initial assumptions you might have, and just confirm to see if you have the right assumptions. And then from there, start brainstorming and then walk through the solution. Don't just kind of like be silent and then say, hey, this is what I think is a final conclusion, walk through that journey of how do you go from the beginning of the problem to the end of the problem, and engage the interviewer in a conversational fashion. Don't turn this into a monologue, because the interviewer also wants to assess to see whether, you would be a good individual to work with, right? And so they're looking for the way in which you can organically interact with them. So always kind of think about this as like, this is not just a technical exercise, but this is also a communication exercise. And so that's why I think it's important when you're doing preparation for interviews, practice the questions orally as much as you can.
Yeah.
Because you're not just simply submitting a question through QuarterPad. You're actually fleshing it out, and you need to be able to explain the solution. So that's something that you definitely need to do. And then the other thing is research. Do the homework and actually do the research. Like, what are the main KPIs? Like, what's the current, if it's like, especially if it's like a product data science based sort of role, like what are the key performance indicators? What are the current values of the metrics, right? So if it's like Facebook, or like what's the current DAU? Familiarize yourself with those things, because when you're on the actual interview or ask certain questions, you kind of have to have some prerequisite knowledge about that in order to be able to address that. So it's about doing research as well. So all it really boils down to is like, at the end of the day, this is like a consultation exercise. So like approach it like a consultant and you're going to be good.
Yeah, thanks for sharing that. So before we wrap up, what is something in your life or career you're excited about?
Yeah, so, at this phase in my life right now, so I've done data science over 5 years now.
Yeah.
And I think kind of gets to a point where, the more, there's a bit of like a diminishing return in terms of like, the more you try to learn something, like less sort of benefit that you're kind of gaining out of it. Because I would say like a lot of I've been exposed to all kinds of problems to a point where I have a really good kind of framework in terms of how I'm going to approach it right off the bat. And so it's not that I want to, so I definitely want to continue to kind of polish and cultivate more in-depth knowledge about data science. So maybe learning a lot more on the latest AI algorithms and those sort of things, right? But generally, what I'm more interested in now is building an actual product out of data science. So running a business that is data driven. So more on kind of IC based, more on kind of management aspect of it. And I think that's a pretty natural cycle for a lot of those people out there. Like, in the beginning, you're like, oh, I don't know why anyone wants to be a manager.
Yeah.
I love the code. Like, I love getting my hands dirty. But for some people, like eventually they would much rather just have a vision and then kind of direct what an AC does in a sense. And so now I'm more interested into just more in the business execution part of it, but I'm still very data driven at the end of the day. I still use Colab quite a bit and use pandas and do a lot of manipulation. For my personal projects, sometimes I might use some, modeling and stuff like that, but it's more just how can I build a data driven company? That's what I'm more interested in. And that's what I'm more excited about.
Yeah, that's exciting. Looking forward to seeing you building it.
Thank you.
And for people who want to learn more about your journey and get interview tips or get coached by you, where can I find you?
Yeah, so you could contact me in 3 different ways. Well, actually, there's 3 different things. But so one is you definitely check out and you can message me on my LinkedIn, just linkedin.com/ and it should just be a username, right?
Yeah, I will link your LinkedIn in the show notes.
LinkedIn. Feel free to message me if you have any questions. You can also email me through my business email. It's dan@datainterview.com. And you can check out the website datainterview.com. And also you could also check out the YouTube channel Data Interview as a way to continue to learn more about what I'm doing.
Awesome. Well, thank you, Dan, for coming to the show.
No, thank you. I really enjoy this.